Hello, I'll be going through question 5 in this video of paper 1. So this question is a fairly standard one initially about a circuit diagram and you showing that you understand how to find the current and the voltage within a circuit. So the first part, it asks you to draw meters on the diagram to measure the voltage of the LED and the current in the LED. So it's already drawn for you. So if you want to find the current, you're going to have to draw the ammeter somewhere that's already on these wires. So I can have the ammeter anywhere in the circuit as long as it is in series. So anywhere in the circuit will be in series. So circular symbol with a clear capital A is the correct symbol for an ammeter. Then it asks for the voltmeter to be put in to find the voltage of the LED. So the voltage of the LED, it needs to go in parallel with the LED symbol. So it's in parallel. So the voltmeter, what it will do is it will find, it says voltage in the question, but it finds the difference between this point and this point in potential. So again, something as close to a circle as I can draw, and then a capital V. There shouldn't be a line through it, and I have seen in other exam questions where if you draw a line through it, you're penalised because that's not the correct symbol. This one makes me uncomfortable as an examiner because I'm going to I have to allow this even though it's got the line through it, but I have seen it where the line through it means you don't get the mark. However, in this case, because of how they've done it, you're forced to do that. So that would get all 3 marks. So 1 mark for the correct symbols, 1 mark for correctly having the ammeter in series, and the second mark is for the correct position of the voltmeter in parallel. The next part of this question is a fairly standard graphing question. So we've got some data and we're asked to plot the points on the grid. Now usually the grid should be designed and set up so there's an obvious good scale to choose, but it might require a bit of thought. So this one isn't the easiest I've seen. Sometimes they're easier than this, but there is still an obvious choice. So if you use a ruler to help you, you can see we've got 12 of these 1 centimeter squares, and we need to go up to 15. So if I was to split this into each 4 squares is 5, and this is milliamps because this is the current. So 1, 2, 3, 4 gets me up to 10, and then that gets me up to 15. So that's just enough to fit all of those points. Notice I'm using a sharp pencil and a ruler, a long enough ruler to allow me to do these straight lines. I'm not finished yet. I need to write in that this is the current, and I need to write what the units of current are, and they are milliamperes, so milliamps. This value is 0, because we have a 0, 0 value that we have to fit in. We have to plot. Lots of people forget to plot 0, 0, or they have a discontinuity with their scale. So what I mean by that is that their scale, if you're plotting 0, 0, then you can't jump from 0 to 10 or 0 to 30 or whatever. You can choose not to start at 0 for a graph, but if you've got a point where you're plotting 0, 0, you cannot do that. So you have to start this one at 0, 0. The voltage needs to go up to 0.6. So can I go 0.1, 0.2, 0.3, 0.4, 0.5, 0.6? Yes, I can. So I will do that. So 0.1 every 2 squares, 0.2, 0.3, 0.4, 0.5, 0.6. Now, I'm using a significant part of the graph. I'm using more than half the graph. I'm going to be using a good proportion of the grid available to me. I'm going up in sensible numbers. So this is going up in 0.1s each time. That's entirely sensible. This one, going up in 5s every 4 squares is sensible. You can be penalised for going up, and you will be penalised for going up in strange numbers like 3s or 7s.